Okay, back with this question. I kept all of my work on a slide that I was just writing in the previous video, so you can still access that. I'll show you in this slideshow, but I made a new slide so that I can have more room here. So kind of going back to this tree diagram, I'm gonna quickly make it again. So, and then I'm gonna cookie, butter cookie, butter cookie, butter cookie. Okay, and I'll write the probabilities underneath. So if you remember the chocolate cookies, we said this probability is 3 out of 10. Butter cookies, this probability was 7 out of 10. We talked about how the probability that we get a chocolate on the second is now 2 out of 9 because that's given we've eaten the first one. Okay, so let's go on to this next case here where we're talking about the probability that we eat a butter cookie on the second given we've eaten chocolate on the first. I guess I should backtrack really quickly. We also found out then that the probability of eating 2 chocolates, so chocolate and chocolate, we calculated to be 3 over 10 times 2 over 9, and we got 6 over 90. We simplified that in our last video, but you don't have to, so I'm just going to leave it like that. Okay. So let's look at this one. The probability that we eat a butter cookie on the second one, given we've eaten chocolate on the first. So instead of writing the formulas at all right now, I'm going to think logically about this. Okay, we ate a cookie on the first trial. So instead of 10 cookies in the box, we only have 9 cookies in the box. But because I'm considering butter cookies instead of chocolate cookies, it's not going to be 2 out of 9. We're wondering how many butter cookies are left in the box if I ate a chocolate on the first one. Well, that's still 7 because I haven't eaten a butter cookie. So there are still 7 butter cookies out of the 9 remaining. And so that's how we're getting these secondary probabilities. I'll call them secondary, but that's not really the name. And so in this case, the probability that we eat chocolate first and butter second, again, I'm writing it in this way, assuming we're okay with the fact that if I write C first, that means chocolate first, and then B second would be a butter cookie second. Okay, so that would then be 3 out of 10 times 7 out of 9. So that probability would be 21 over 90. Again, we could simplify that, but I'm not going to for the sake of this video. And maybe as a reminder with fractions, in case this isn't clear, when we're multiplying fractions, we multiply the numerators and multiply the denominators across. I know students sometimes have a tendency to want to find like a common denominator. That happens when we're adding or subtracting fractions, which we will get to at some point. We might have to do that. But for now, we're multiplying, so we can multiply the numerators and multiply the denominators. Okay, so this next one where we have a chocolate second, so I'm on this one here. So I'm wondering what's the probability that I have a chocolate cookie second given I've already eaten a butter cookie. So let's talk about it. I've already eaten 1 cookie, which means I'm back to 9 cookies. I don't have 10 cookies in the box anymore. And out of the 9 cookies, my question is how many are chocolate? And given the fact that that first one I had was butter, not chocolate, that means we still have 3 chocolates in there. Okay, so that means the probability that we have butter and then chocolate would then be 7 out of 10. So we're taking this probability that we eat a butter first, multiply that by the probability that we have chocolate second. So in this case, we also get 21 out of 90. Alrighty. Now, the last one, butter and then butter. So we're looking at the probability that we have a butter cookie and then another butter cookie. So again, we're back to 9 cookies. Notice on the second trial, all of these are out of 9 cookies because we're assuming we've eaten it without replacement. These are dependent, so the probabilities will change from trial to trial. Okay, so now there were 7 butter cookies to begin with. We've already eaten 1, so there's only 6 remaining. So that's how we can get that probability. So the probability that we have a butter cookie and then a butter cookie is going to be 7 out of 10 times 6 out of 9. And we get 42 out of 90. Okay. So I want to clarify again, these are our events. Here, I'll maybe What color should I use? Yellow. Our event CC means this is one event that has 2 trials. This is one event that has 2 trials. So there are 4 total events that are possible here. And we have found the probability of each of those. On a tree diagram, these should all add up to 1, like all these fractions should add up to 1. So if we quickly do that, 42 plus 21 is 63, plus another 21 is 84, plus 6 is 90. So we'd get 90 out of 90. So checking our work, that makes sense to me. I also want to make sure we are using, I'll say, critical thinking to kind of check our answers. So I want to maybe ask first and pause the video if you would like to. Does it make sense that the highest probability, so if we eat 2 cookies from this box, does it make sense that the highest probability corresponds to them both being butter cookies? I'll just even pause because I'm used to teaching in person. So does it make sense that if I said, what do you think would happen if you ate 2 cookies from this box? What would you bet on, for example? It would make sense that you would bet that you would eat 2 butter cookies because there are the most of those. So it makes sense logically to me that there would be a much higher probability that you would end up having both butter cookies than any of the other scenarios or other events that could happen. Okay. So that's how we write out the probability. And I know that I kind of format my tree diagram differently than maybe you've seen in the text or in the Khan Academy videos. But for me, this is just how I did it. So this is the tree diagram. We've written the probabilities along each of the branches, and we actually calculated the probabilities for each of these, which is jumping ahead. But I just wanted to talk through that. Okay, part B. And I notice I'm at 7 minutes, so I will see how quickly I can do this. Part B asks, are the probabilities for the flavor of the second cookie that you select independent of your first selection? So I did explain that in the first video. Because we are eating the cookies, so eating cookie 1, that directly implies we're doing something without replacement, meaning we are changing the probability on the second trial that we have. So is it independent of our first selection? No, because the second probability changes depending on what happened on that first trial. In other words, if I just asked you, what's the probability you eat a butter cookie on the second trial? Well, your response might be like, well, it depends. What did I have on the first time? And that's exactly, that means that these are not independent. Okay. For each complete path through the tree, write the event it represents and find the probability. So again, I answered that all kind of in these, so I won't go over it again, but I wanted to acknowledge that I'm answering A, B, C already. So part C is this same chart. In fact, maybe I will copy and paste it so it's there. Okay. And since I'm at 8.5 minutes, I'll go ahead and stop this one. And then for the rest of the questions, we can talk through those in a different video because those are a little bit more intricate, complex. So we'll do that. All right, that's it for this video.